Hello and welcome to this presentation about AI in software development. The intended audience is students in VCE computing in Unit 1. I do have a separate presentation for Unit 3 which I'll probably link to in the comments. So the study design says that we're looking at emerging trends in programming using artificial intelligence, including low-code development approaches and the readability and maintainability improvements. So I am definitely going to talk about those things. I'm also going to give you just an overview of AI because I'm amazed by what misconceptions there are out there. So what do we already know? Well, how does generative AI create its responses? Does it copy and paste them from existing content? Does it train humans typing responses? Is it using patterns learned from training data to generate likely responses? Or does it store every possible question and answer in a giant database? Now, some of those might seem silly to you, or they might actually seem completely plausible to you. But in some cases, all of those things have been true, but they are the outliers most of the time, and most of the time it's actually somebody engaged in some kind of, deception, for want of a better word. But number 3 is what it actually does. It uses patterns from training data to generate likely responses. What's a limitation? It can make up information, it can be too slow to be useful, it can only copy and paste existing answers, not generate new ones, and take too much processing power to work on consumer level devices. So, having a look at all of these, the one that's actually true is that it can make up information. Now this is actually called hallucinating, and it's part of its predictive process, believe it or not. It, like we do, it says, well, given the information you've got me, this is what I think is true, whereas we might say, I think it's true and express some doubt. AI tends to just present it as fact. And this is frustrating and a real trap, because it can come in with things and say, this is what's true. A really common example of this is people saying, I want to take my car to the car wash, which is 100 metres away. Should I drive or walk? And it's looking at all the stuff about driving and walking, and it suggests that you walk, that it would be wasteful to drive. And of course we know that you need to take your car to the car park. Number 2. Some models are slower than others. Like Gemini, at the time I'm recording this, is really slow for some things. Tremendously useful answers, but if you ask it about something to do with programming, it can take minutes to come back with a response. Number 3 is just not true, although it is disturbing how often AI just reproduces blocks of code, which is something that, according to the theory, it shouldn't do, but it does. And take too much processing power to work on consumer level devices. You can actually run an AI on quite a modest device these days. It's not going to be as powerful as the ones on the big servers, but you can do it. What does training data mean in relation to generative AI? Well, is it the questions that users ask the AI system each day? Is it the instructions that programmers type in to tell the AI what to do? Is it the large collections of examples that the AI learns patterns from before it's released? Or is it the practice exercises that AI completes to improve itself over time? Now, all 4 of these are actually done in one way or another, but when we say training data, we're actually talking about number 3, the large collections of text that particularly large language models are built on. And finally, so what does it do? Well, it uses these things called deep learning techniques to analyse large sets of data, to identify complex patterns in it, and to generate probabilistic content representations. All that means is, what is probably the answer to this? And in truth, that's how a lot of us work too. From what I know, what is probably the answer? And to create new outputs based on learned structures. So it knows the structure of what you're asking, but it hasn't necessarily heard that question before. And this is where AI is new and different to what came before it. So it has 4 core technologies which are under the hood. The one that most people know about is large language models. So neural networks are also involved, machine learning algorithms and transformer architectures, and we're going to look at all 4 of those. Well, first of all, what is a large language model? This is what most people think AI is, and there's certainly a lot of truth to it. It's trained on massive amounts of text and picture and video data to understand and generate human-like responses. Probably the biggest amount of data it can chew through is text rather than pictures and so forth, but it's not limited to text. There are ethical and legal issues about using data for training without permission and or compensation. If I read 5 vampire books and then I wrote a vampire book, nobody would expect me to compensate the authors of those 5 books. But the fact is that it's still a very limited process. It takes me time and intelligence to read them and synthesise them and then to write the books. But if these systems can just hoover up every work of Shakespeare and then just write new Shakespeare, and I don't think it can do that yet, but let's say it can churn out new Harry Potter books, well, somebody's got a copyright to that universe, for better or worse, and so it would be effectively stealing their franchise again, for want of a better word. It looks for statistical patterns and relationships between words by analysing billions of text examples during training. So it doesn't actually know what a queen is to start with, but it looks at the word in the context and it builds relationships and says, hey, the strength of how often we say it with monarch and king and ruler and government and all of these things, and it builds it into a web, and it's got these tokens which have got connections to other things, and that's how it knows what the word queen probably means. It's got an understanding of grammar, context, facts and reasoning patterns. So it can solve some of those problems about, 2 trains are heading towards each other at this speed, because it understands types of reasonings. The next thing we want to have a look at is neural networks. Now this is based on what goes on in our brains, where we have neurons and we have paths between them. And the more we do things, the stronger those connections get between them. I think of this like walking across a grassy field and making paths. And the more we walk the path, the more solid and deeper it gets and the better it is to walk on. And so we use that path more. So there's the input layer where we put sort of a question in one end, and then the hidden layers where it goes through all the neurons or the nodes along the way, and it produces the content. And what we're really trying to do is build up the strength of connections between the dots that actually work well to get us to good answers. So that actually comes back, well, it doesn't come back, it leads to one of the ideas in machine learning, which is supervised learning. So let's say that I show you tagged data. I say, this is Sergeant Pepper's Lonely Hearts Club Band, and so is this, and so is this, and so is this, and so is this, and so is this. And it actually learns from all of those. It goes, oh yeah, all those things are the same object. They're all that record. The next one is just looking at a whole heap of images and text and saying, oh yeah, I reckon those ones are the same. But that's unsupervised. And the final one is reinforced learning. So imagine that you said, we'll build competing algorithms to try and identify that album, and then the one that gets the most of them right, we give it the answer sheet at the end, and we say, okay, we're going to reinforce that model. So there are 3 models of machine learning. This last one's a bit egg-headed, but I'm going to go through it quickly. These are called transformer architectures. They turn one thing into another. So there's a self-attention mechanism which looks at the importance of those tokens I was talking about, where you have the ideas of, say, queen and king and monarch, and it says, well, some of these are more important than others in what I'm dealing with. The encoder-decoder structure means basically we've got a different algorithm for reading than we have for writing, that they're 2 separate architectures. And then there's positional encoding that looks at the sequence of words and concepts in a prompt. So let's see what we know. Well, what do we call a technology where large amounts of data are analysed for patterns and meaning? Well, that's a large language model. True or false, all connections end up with the same weight in a neural network? Well, it actually wouldn't be a very good neural network if that were true, so that is false. One of the models of machine learning is supervised learning. There's also reinforcement learning and unsupervised learning. And what does positional encoding mean as a transformer architecture? Well, it means that it looks at the order of the words in the sentence and says, well, some of these are more important or have different meaning depending on where they are. So we are now back at what's explicitly stated in the curriculum. So we've got low code development. This is where we write in natural language, and then it creates code for us. You describe the functionality in your own language and it gives you back working code. So I've got these things that I'm going to give my class to do, and I'm going to show you an example that I made a bit earlier. I said, please make me a program in Python that takes a sentence from the user and responds with a judgment if that user is happy or sad or neither. So there's the code that it gave me. I've got it here in Thonny, and I'm going to run it. There you go. How are you feeling? I am feeling sleepy and sad. Sleepy and out of sorts. And let's see what it says. Oh, okay. So in actual fact, it didn't really pick it up there because I was being too general with out of sorts. I feel fine. Neither happy or sad. Oh, there you go. So it's actually not looking for many words if you look up there. It's not a very sophisticated program, but there we have it. So that is an example of how we use that. We talk about what went well and what are possible downsides. So we also have intelligent code completion and suggestion systems. Cursor is a good example of this as of April 2026. This area is just changing so quickly. Cursor is a good example that it will look at how you code and it will actually allow you to say, oh, here's what I think you're going to say next, here's what you want to say next. It's fantastic. I love it to bits, but it's a bit expensive. It can create documentation for you, and it can find bug detection and code optimization. The bug detection is fantastic. I used to say that we spend 90% of the time writing 90% of the code and the other 90% of the time writing 10% of the code. Now we can actually resolve some of those really thorny issues much more quickly. AI is really good at spotting those. And apparently you can generate a program from a user interface or sketch. I've never done this. So the last thing we want to talk about is readability or maintainability improvements. So it might do something as simple as renaming variables and functions to be more descriptive. It might add or improve on your comments and documentation. It might restructure your code to follow consistent patterns. It might break a complicated function into smaller, more modular or focused units. It might go through and identify and remove redundant code or inefficient code, and or suggest more efficient or cleaner algorithms. So that's the end of this presentation. I hope you found it useful and learnt something along the way, and I'll see you in another video.